Alrighty. Let's go ahead and take a look at this one. On this 3 to the x. Thank you, thank you. So, what do we do? Yeah, we gotta draw our own table. So we're gonna make ourselves a little table. Pick some x's to find some y's. What x's should we pick? -2, -1, 0, 1, and 2. Do we have to pick those values? No. Are they the easiest options we've got? Yes. Those 5 are the easiest ones. I recommend sticking with them. If you want to go out further, you totally can. More power to you. So what are we getting for y values when we have these? What goes with our -2? 1/9. Good, because 3 to the power of -2 is 1/9. And you can put those in the calculator. Like, the calculator can do that. So our -1 is going to go with what? 1/3. 0. 1. What goes with the? Yes, yes on the 1, going on to the next one, 1. 3. And then to go with the 2? 9. We are taking our x's that we picked, and we are substituting them in up here. So 3 to the power of 2, so 3 squared, that's where we're getting our 9 from. 3 to the 0, if we type that in the calculator, it's going to spit out a 1. Okay. Yep. Where's our asymptote on this one? 0. So the equation for our asymptote is y equals 0. You have to write it as an equation. It has to be y equals. And all that means is that our x-axis, this guy, is our wall that we cannot cross. We don't typically draw it on parent functions because it's our same thing as our x-axis and it's just visual clutter. But you can. It just makes things really messy, especially when we get to transformations. So all we got to do now is plot up our points. We've got our -2, 1/9, which is ish there. -1, 1/3. Again, especially with the fractions, we are getting it close-ish. It's an ish. If we need graphing perfection, we use a computer to do so. Bless you. We do not expect 100% micro precision from hand graphs. Do not worry about the fact that my 1/3 and my 1/9 look shockingly similar. It's close. It's giving us the vibe. My 0.29 is also off my graph, so we can either estimate it being somewhere way up there, or we can go like, hey, I got a point up there yonder somewhere, and use that to draw our arrow. But when we connect them up and we do not go through the wall, ding, we had a clever idea. Our graph should look like this. What's our domain? And that will always be our domain. -infinity to +infinity. What's our range on this one? 0 to infinity. Just like this. Okay? So what I want us to do is I want us to practice the transformations again. They're not really going to get worse than yesterday's or the one that we did on Monday, but I want us to practice those again because we have a couple of transformations that we haven't worked with super frequently or that we haven't seen in a minute. So we're going to do a couple of them, okay? So I'm going to put it up here, our first transformation that we're going to work with, and we're going to pass out graphs. I've only really planned on for us to do 2 of these, but honestly, I wasn't going to come up with a graph and give me a separate. Because there's scissors in the box if you don't want to have a spare row, or like have a gift of a graph. And I'm just going to say to those of us that are napping in or watching our phone, yeah, that's not bad. Feel great, your choice. How many times do you want to take this class? We did number 5 on the homework.
Oh, yeah, yes.
Because that way we didn't remember how to graph it home. All right. So this is our first graph we're going to do today. We've got h of x, which is 2 times 3 to the power of x minus 1, and then minus 5. So first things first, let's figure out what pieces we have here so we know which parent function we're looking at, because I didn't tell you. So I put up here our transformation form. We will have this for you on the test. It's printed on the paper. What is our a for this function? 2. It's this number multiplied out in front, which makes the 3 what? The base. That's going to be what our parent function is based off of. So b being 3, that's my base. That means the 3 to the x is my parent. So we're going to draw a table for our 3 to the x in just a second. Let's finish finding our pieces. What is my h going to be here? 1. It always has the opposite sign of the expression, so the fact that this says x minus 1 means my h is a positive 1. And what about my k? Negative 5. So what do we expect these transformations to be? What does this mean? Down 5. The k tells me how it's shifting vertically, so that would be down 5. Not right 2. Which one does our horizontal shift? H. So since h is 1, that's going to move to the right. A, that's my one that does our stretch versus compress. So since A is 2, it's a big kid, it does this big kid yoga, it does a vertical stretch. If it was a little number like a fraction, that's when it's a compress because it's so cute, I just want to squish it. And then if it's negative, we get that vertical reflection, that reflection across the x-axis. So this one's going to have a vertical stretch. We're going to go right 1, and we're going to go down 5. So first things first, we got to start with our parent table. Our base is the thing that tells us that. So that 3 to the x. Oh, wait. We just did that one in the bell work. What? So that's when we pick our x's, our minus 2, our minus 1, 0, 1, and 2, so that we can find our y values by substituting that in for our power. 3 to the power of minus 2 is our 1/9. 3 to the power of minus 1 is 1/3. 3 to the 0 is 1. Anything to a 0 power is 1. 3 to the first is 3, and 3 squared is 9. So I am going to plot up my parent function again. I know it's just like the one we did in the bell work, but I'm still going to do it. And it should look something like this. So there's our parent. For our transformed function for our h of x. Yes? I didn't even put the colored pencils away. If you want more than one color, I have a whole bin of them.
same colors as everything.
That's fine. To get our transformed function, that's when we're going to take our x's and we add h. And we'll take our y's. Remember how much graphing makes us yak. Ya plus k. So that means what we're doing is we're going to be taking the x's from our parent function and adding h. So we're going to add 1. We're going to take our y's times our a. So we're going to go times 2 plus k plus -5 or -5. So we're just taking the values we found up here and substituting them into this guy. So we're taking our x values from our parent function. So I'm going to take my -2 and we're going to add 1. To not stop here? Mm-hmm. If we have, my lazy pointer stopped. If we have any of these outside values, because this just does the 3 to the x. It just did that bit. No 2, no 1, no 5. It just did the 3 to the x. So that's what we start from, and then we're going to move it with the 2, the 1, and the 5 into this guy. So we're going to take our x's from over here, and we're going to add 1. So my -2 plus 1 gives me a -1. My -1 plus 1 gives us a 0. 0 plus 1 is 1. 1 plus 1 is 2. And 2 plus 1 is 3. Our y's are going to be a little bit harder. We can use our calculators. We can put them as decimals. We can keep them as whole numbers. But we have our 1/9 times 2. So then 2/9, and then -5. That's going to be -4 7/9. Or if you hit the 2 arrows on your calculator to get it decimally, we should get -4.77777777.
I forgot we're doing the y's from over here.
Doing the y's from over there.
So I did this and I got a linear.
Yes, dear.
So what do you do a decimal form?
You can put it in a decimal form. Totally fine. With our, especially when we're graphing by hand, we are estimating. We're getting it close. Yeah, you can totally switch it to be a decimal. And on the yellow calculators, it's the little button that looks like this with the 2 arrows. It's right by the enter button.
Oh, yay. Repeating 3.
Yep, so on the next one, we have our -4, and we would have 1/3. Or, again, to switch it back to a decimal, use the 2 arrow button. I get -4.3 repeating. Blah, 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 blah. And then we're out of the world of fractions. Yay! We get 1 times 2, which is going to be 2. And then -5. It's going to give us a -3. 3 times 2, which is 6, -5, and we're into the positives. Woohoo! 1. And then we get 9 times 2, which is 18, -5, 13. So way up there. Where is our asymptote for this one going to be?
5.
Almost. -5. Y equals -5. We have to write it as an equation. Y equals -5. That means on our graph at -5, we are going to draw a dotted line. A horizontal dotted line. You have to put the asymptote on there. Do not do it without the asymptote. You will lose points. Go ahead. It's a K. Every single time it's Y equals K. Every single time. So we could, as soon as we find this, we know that it's this. Every single time. At least for exponential functions.
totally not.
For this chapter, 100% of the time it's K. So then we're going to plot up our points. Our -1, -4, and a lot. So -4.8-ish. 0, -4 and a third. 1, -3. 2, 1, and 3, way off the graph. And we can see here, we still get that classic exponential swoop. We've still got our wall that we cannot cross. We get a graph that looks kind of like that. And if we look at our parent function, those transformations that we expected absolutely happened. This Leibniz function got moved down 5. It got scooched over a smidge to the right. And it got stretched taller. If you look in this little swoop, you can see it, the space between these dots. It's been stretched. What is our domain on our transform function here?
Negative infinity to positive.
From negative infinity to positive infinity. That is our domain every single time for every single exponential function. Every single one. What's our range on this one?
Negative 5 to infinity.
From -5 to infinity. Our asymptote will always be involved in our range somehow. And in this case, it's the absolute lowest this is going to really, really, really try to get to. Okay. Questions on this one? We're going to do one more. And that'll be the last one. But I want us to see one more set of things. So here I give you K of X. We've got -1/3 times 2 to the X plus 5. And then plus 4. So when we get things like this, start with identifying our pieces. What's our A, our B, our H, our K? What do we see? Our A is that -1/3. I got you. What does that mean is going to happen? What is an A of -1/3 going to do? It's going to be compressed and flipped. It's going to reflect over our x-axis. That negative is going to make things flip. It doesn't change how we do it, but it is going to make things look different. What else do we see up here? Our b is going to be that 2 to the x. Good. That's our parent function. That's where we start. Our base is 2. So that means our parent function is going to be that 2 to the x. What else we got?
H is -5.
Good. H is -5. It always gets that opposite sign of the expression we see there. So which direction do we expect this thing to move? Left. Last one. K is 4. So which way is that going to move? Up 4. So my K is 4. So I could write at this point, come down here and say, oh, I know on my transform function, we're going to have our asymptote at y equals K. Or in this case, it's y equals 4. I'm not going to draw it in yet because we want to graph our parent function, and I don't want us to get confused on the asymptote. But we know it right there. I don't have to wait and write it later on. So let's do our parent function first. That's where we pick our x's to find our y's. Again, we do not have to use these values, but these are the easiest ones to work with, and they give you a reliable view of the center. So I highly recommend them. Yes, dear. Yes, give me just a second. So setting up our parent function, what are we going to get as our y values? 1/4, good. 1/2, 1, 2, and 4. So plot up those points. And we're going to get that our parent function looks like this. We substitute them into that 2 to the x that we found. So we pick these, and then we say 2 to the power of minus 2. Or 2 to the power of minus 1. 2 to the 0 gives us 1. And we can type those in the calculator. The calculator can do it for us. Fully valid. So the parent function is a tool that we use to find our real guy. We really want to have k of x. So what we really want to have is our transformed function. This is the guy we're looking after. So that's when we take our x and we're going to add h. And we always remember how much graphing makes us yak, ya plus k. So we're going to take our x values from our parent function and we're going to add h. So we're going to add -5, or in this case, that means -5. We're going to take our y's times -1/3, and then we're going to add k and then plus 4. So this one is going to get decimally and gross. And that's okay, we can do this. So we take our x's from over here and we're going to subtract 5. That's going to give us -2 minus 5, we get -7. -1 minus 5 is going to give us a -6. 0 minus 5 is -5, -4, and -3. Give me 1 or 2 decimal places. Honestly, with graphs, we're getting ish. 1 or 2 decimal places. So this one is going to get icky, and it's decimally, and it will be decimally for pretty much all of them. But we're going to take our 1/4 times our -1/3, which, if we do that by hand, is a -1/12, and then plus 4. We should get 3 and 11/12, which will be 3.8, 3.9-ish. Right? What do we get decimal-wise? 3. The first one? 1/4. 3.92. I was going to say, I was doing it in my head. I was getting it close. I'm like, that's about as far as I could go. Then we're going to take our 1/2 times our 1/3. Excuse me. Our 1/2 times our -1/3. It's going to give us -1/6 plus 4. So we'll get 3 and 5/6. Which you can put as a decimal if you'd like. You can also keep it as a fraction. Then we're going to have our 1 times our -1/3. We can do -1/3 plus 4 becomes 3 and 2/3. Two times -1/3, and we get -2/3 plus 4. We get 3 1/3. And then our 4 times -1/3, we get 4/3 plus 4. We should get 2 2/3.
I did
Decimals, totally fine. What'd you get? That one's 2 point.
For that one, 2.67.
Is it 6? Yeah, 6 repeating. 6, 7. So this one would be 3.3 repeating. This one's 3.6 repeating, and this one's 3.8 8?
Well, I rounded to the second decimal place.
Okay.
So for the y for -6, I got 3.83,
Mm-hmm.
and then for the y for the y for -5, I got 3.67.
Yep.
And then for 4, I got 3.33.
Yep.
And then
Absolutely valid. I do not care if you do them as fractions or as decimals. I just couldn't reliably switch them to decimals in my head, and I didn't do the calculator very easy.
Even if it's a reading decimal.
When we're graphing, honestly, the which place we're at doesn't matter. If the number after, like the reason this is 3.67 instead of 3.66 is because this is 6 repeating, 6, 6, 6, 6, 6, blah, blah, blah. So by rounding here, since this number is more than 5, it pushes that guy up. That's how we decide where we're rounding. So, but honestly, with the graphs, we're estimating. We're getting it close. So on this one, we're going to get our asymptote up for our parent, or for our transformation up here. We have our asymptote at our y equals 4, so it's way up here. And when we start plotting up our points, our -7, 3.9, mine's off the graph. I think I gave you guys at least big enough so you can have it.
we have up to 10.
Yeah, I can eyeball it over here. Our -6, 3.8. -5, 3.6. So these are all really close to that asymptote here. My -4, 3 1/3. And then -3, 2.6. So we can see it is finally starting to look like it's curving a little bit. We know it's going to approach this asymptote over here. But it's finally starting to curve a little bit. But it's facing the wrong direction because we had that negative transformation in the A. We had that reflection. So what's our domain on our transform function on our dark blue graph? Or k of x. What's our domain? Negative infinity to positive infinity. It will be that every single time for exponential functions. What's our range?
4 to -3.
Yes, but we tend to write them smallest to biggest, so we're going to flip-flop them. So we're going to go from negative infinity, because it's the smallest, up to 4. So our asymptote's involved, but it's in a different spot this time, because we go from smallest to biggest. Okay? Questions on these? Because they don't really get worse. They're just awkward. That is everything you need to know about exponential functions.
How many graphing on our review or our homework?
What's up?
Do we have any graphing on our homework
Yes.
or our review?
On the back of that homework has graphing, and on review, the very back page has graphing.
And so I can take these. So I can.
Yes. Yeah, you can borrow. Totally fine. Okay, if you need a copy of any of the homeworks, they're up in the hanging folder. Same thing with the review. I'm going to pass back all of the homework that I have as of right now. Please make sure you double check things in grade books. They are pulling report card grades at some point today for quarter 3. So, yeah, make sure we know how things are doing before we get that information.